Hey everyone, welcome back to TryHackMe's Advent of Cyber 2. I'm Dark, and today we're going to be doing Day 5, Someone Stole Santa's Gift List. So for Day 5, after last year's attack, Santa and the security team have worked hard on reviving Santa's personal portal, hence Santa's Form 2 went live. After the attack, logs have revealed that someone found Santa's portal on the website and logged into his account. After doing so, they were able to dump the whole gift database, getting all the 2020 gifts in their hands. An attacker has threatened to publish a wishlist.txt file containing all information, but happily for us, he was caught by the CBI, the Christmas Bureau of Investigation. Look it up, it is a real thing, I promise you. I'm totally not making that up before that. So on, this is going to be our website IP, and I'm going to go ahead and bring that up while we're doing this. Now, one thing to note, I have already started the box that I'm going to be attacking, as well as the attack box. You can start the box for this task by clicking the deploy button here, and then you can start the attack box by clicking the deploy or start attack box button at the top right of the page. We're going to go ahead and pull this up though. 1010 242 148, and this will be different for you. If you end up getting the same IP as me, good for you, but it'll very more than likely be different. It looks like the page is a little squished, but here we can see that we have our web page that we're going to be attacking. You'll find a copy of the website, and your goal is to replicate the attacker's actions by dumping the gift list. So we're going to figure out how they did it by trying to do it ourselves, and then we're going to see if we can prevent that. So what is SQL injection? A SQL injection, otherwise shortened as SQLi, attack consists of the injection of a SQL query to the remote web application. So what is this? We are interfacing with the database, and SQL is the language that it actually uses to, that's how you do searches. So that's how you parse through the data to find different things. SQL, it is pronounced the same way as like a movie sequel or just a novel sequel. But that is your base query language. There's some extensions on that, but that's really all you need to know for doing this task. A successful SQL injection exploit can read sensitive data from the database, so usernames and passwords, modify database data by either adding or deleting things, execute administrative operations on the database, such as shutdown, and in some cases, execute commands on the operating system. This is select because some databases will prevent you from doing that. However, it does happen a lot. SQL background. SQL is a language used in programming to talk to databases. It's an extremely handy language that makes it easy for the developers to organize data in various structures. Unfortunately, the benefit always comes with a drawback. Even with a little misconfiguration in the SQL code, it can lead to a potential SQL injection. I advise you to quickly go through the SQL command guide in order to make yourself familiar with them. So this is worthwhile digging through. Code Academy is fantastic as well. Dig through this, just take a look at some of the basic commands. I'll pull it up here for just a moment. And here we can see that we just have some of the basic stuff. Let's see. So there's delete, so you could delete things. I'll make this a little bit bigger for the sake of recording as well. So delete, let's see, insert would be adding new things, and so on and so forth. And you can see that there's just a whole bunch. Definitely worth digging through though. So spend a few minutes on that. In any case, in the SQL injection attack, we mainly use 4 commands: select, from, where, and union. So let's go through those commands. Select, and this is actually linking through or to the W3 schools so you can see a little bit more for these, is used to select data from a database. And we'll go into this more in just a little bit and what this specifically is doing. From is specifying what data we want to, or what table we want to take something from. So things are organized into different tables that are usually like users or items or orders, things like that. Where, and this is going to be our condition, so what we actually want. So where order number equals 1 or username equals admin. And then we can use union, which is to combine the result set of 2 or more select statements. So say that we have 2 statements that we want to get, maybe we want to select a couple different customers and we want to find everything that they've ordered. That is going to where we would use union in that case. It is important to mention that 1 equals 1 in SQL stands for true. This is a statement that is always true because 1 does equal itself. Shortly, you'll see the reason as to why I mentioned this, and we're going to abuse this statement. However, you can do it with 2 equals 2, 1 equals 1 is just what everyone uses because it's very easy. How does a SQL injection attack work? SQLi is carried out through abusing a PHP get parameter. For example, question mark and then username equals or ID equals in the URL of a vulnerable web page, such as those covered in day 2. These are usually located in the search fields and login pages, so as a penetration tester, you are always going to want to note these down. Whenever you have somewhere that you can search or log into, you should be mapping that as somewhere that should be investigated either for SQL injection or even sometimes with search fields, you can actually get cross-site scripting out of that. So something definitely to investigate. Here's an example of a username input field written in PHP. So here we have just a simple PHP page, and we're getting the username item from the parameter, or from its parameter in the GET request, which we talked about, I believe, in day 2. And then we have our actual query statement here. So we're doing a select. We want to get everything from the users table where the username equals the username that was provided here in the GET parameter. After a variable username was inputted in the code, PHP automatically uses SQL to select all users with the provided username. Exactly this fact can be abused by the attacker. So we're looking for something and we're going to try to make that condition equals true, because that actually is what happens when you log in. It's checking against a database and making sure that your user, 1, exists, and then 2, make sure that your password is what the password is you've previously set as. So it's doing that comparison, and if it finds that it's true, it allows you to log in. That's when the website is going to grant you a cookie and all that fun stuff. Let's say a malicious user provides a question mark, or quotation mark rather, so just a single quote here as the username input. Then the SQL code will look like this. And that, if you've programmed it a little bit before, you'll know that this is wrong. You need to have a quote to end this. You need to have them in pairs, otherwise things start to break. As you can see, that mark creates a third one and generates an error since the username should only be provided with 2. Exactly this error is used to exploit the SQL injection. So whenever you see an error that's produced just by chucking a single quote in or a double quote, that's when you're going to go through and you've got SQL injection. Sometimes you won't get anything back from that, and that's when you'll have blind SQL injection or things like that. Generally speaking, SQL injection is an attack in which your goal is to break SQL code execution logic, inject your own, and then fix the broken part by adding comments at the end. So what we're doing is we're actually taking the query, our search that we were doing beforehand, and we're going to add things on the end of it to make that statement true, and then we're just going to comment out the rest of it. So what would that look like? In this case, we can see an example here where maybe we have our ID equals 1 that we want to go after, which this usually is going to be the admin, is ID equals 1 or ID equals 0. And then we're going to comment out the rest so we don't check the password. So that's adding these 2 dashes here and then a space. And that's going to go through and it's saying, hey, anything that comes after this SQL, the actual database is going to ignore the rest of it. It's saying that it's not actual SQL code. So the password check is just ignored. And we can see how we've got the ID equals 1 and 1 equals 1, or ID equals 1 or 1 equals 1. It just depends on what you're trying to get out of it. And here we can see that we're commenting out the rest of that. So the graphical interpretation, generally speaking, we'll have the 2 dashes here, and then we will have, this is another way to comment things out as well. The / and then a star or asterisk. Login bypass with SQL injection. One of the most powerful applications of SQL injection is definitely login bypassing. It allows an attacker to get into any account as long as they know either the username or the password to it. Most commonly, you'll only know the username, as that's typically what people give out, and that's public. First, let's find out the reason behind possibly doing so. Say our login application uses PHP to check if the username and password match the database with the following SQL query. So we have the select username and then password from the users table. So we're looking at these 2 columns from the users table where the username equals the username that we provided, and then the password equals the password attempt that we provided. So if these 2 match, then we're able to log in. As you can see here, the query is using inputted username and password to validate it with the database. What happens if we input the single quote or true equals or true and then 2 dashes? Username, we would put that into the username field rather. This will turn the above query into this. So we're checking our username now, but it's just empty, or we're looking for just true, and then the rest of it is actually just commented out because we've added these 2 dashes here. The 2 dashes in this case has commented out the password checking part, making the application forget to check if the password was correct. So it's only checking one thing, and it's checking to see if you have the right username. This trick allows you to log into any account by just putting a username and payload right after it. Note that some websites can use a different SQL query such as username and the password, so just a little bit different here. And in this case, you see that we have parentheses that we need to work around. So in this case, you need to add a single parenthesis to your payload like this to make it work, because you're closing what's already there, and then you're adding on your bit after the fact. You can practice login bypassing on the deployed machine on port 3000. So we can go ahead and we'll copy this, and we're going to change that 8 to a 3, which is a nice little feature. So here we can see that we have anything, and then we're going to add that, or true, and then make sure we have a space at the end of that. And here we can see we have actually our full query there, this is very problematic. You don't want to give the full query to the user if something happens. Here we go. So it looks like we don't need this parenthesis. Let's try it without that. Yeah, you can see that if we played with this a little bit more, we would be able to bypass this. Yeah. So what we're doing is we're actually matching up. We had that single quote at the start of this, and then we're adding that single quote at the end of this, or true, which can be 1 equals 1, and then we're commenting out the rest of this. And we can go back. So we'll play with that a little bit more. That's something that you can play with on your own time if you want a little bit of extra practice, and I definitely recommend doing so. I put an extra interactive exercise there. It'll show you all the backend output, allowing you to experiment and practice with SQL commands. So blind SQL injection. In some cases, developers become smart enough to mitigate SQL injection by restricting an application from displaying an error. So it doesn't display anything back. And this is pretty common if you have a web application firewall, that it's just going to say that, hey, if you're trying to input this or we see any of these characters being returned, it's not actually going to return the page. So they've been smart enough to implement that by not displaying the error. Happily, this doesn't mean that we can't perform the attack. It just makes it a lot harder. Blind SQL injection relies on changes in the web application during the attack. In other words, an error in the SQL query will be noticeable in some other form. So for example, we'll change content or something else. Or it just takes longer to load because we are causing a sleep function to hit, so that it's just waiting. The web server can't load because it's performing that sleep function. Since in this situation we can see if an error was produced or not, blind SQL injection is carried out through asking yes or no questions to the database. Or rather, we can only see if something has actually changed in the web page. So in this way, we can do binary tests to see if something has actually happened. And we can see that here, where in this first example, we don't have anything that's displayed, and then we have the URIN that's displayed with which would be the difference of if something actually happened or not. So through that system, an attacker can guess the database name, read the columns, and so on and so forth. We have automated tools for this in the form of SQLMap, and we're going to be exploring that in just a little bit. Blind SQL injection will take more time than the other types, but can be the most common one in the wild. Start off by finding a way to cause the SQL error and then fixing it back. So here we can see that we just have their example here, and we can cause an error by just inputting that single quote here, and it's just nothing works. Now we can fix that by going through and commenting out the rest of it so it doesn't actually try to do anything. So fixing it, notice how the web app didn't output any error, even though I've clearly caused a SQL error in this first one. For asking the questions, you'll use the substring SQL function. it extracts a substring from a string and allows us to compare the substring to a custom ASCII character. So what we're going to do is actually do a comparison there that is going to generate a true or false, and depending on that, we can get output back. So the above table is asking if the database, if its first name, or if the name's first letter is equal to 155, which is going to be a lowercase s in an ASCII table, and you can view that here. And we're attempting to go through, we'll cycle through each letter in the alphabet and then the numbers 0 through 9, just to see if we can guess that first character by performing this binary test. We'll go through and say, hey, is it A? Is it B? Is it C? And so on and so forth. But we can do this with an automated tool. And now we would put in this payload where specifically we would have the and then we're doing that substring comparison to see if we can get something back. And in this case, we can see that we're getting this true here because text is returned on the page. And we saw before, again, that nothing was returned when we had that error. So the payload is the question. If the application does not produce any changes, then the answer is yes. And the database's answer in this case is, or the database's first letter is S in this case. So we're asking the question and we're seeing what we get back. Any change or any error or change would be no in that specific case. Note, you can use blind SQL injection techniques in the open situation as well. So you can try these blind SQL injection techniques against the 3000 port as well, just to play with them and see what different errors you get back. Union SQL injection. Union SQL injection is mainly used for fast database enumeration, as the union operator allows you to combine results of multiple select statements at a time. Union SQL injection attack that consists of 3 stages: finding the number of columns, checking if checking the columns, or if they're suitable rather, and then we're going to actually run the attack and see if we can dump all the data. So we're going to do the number of columns first, which is going to be, we have to do a comparison 1 to 1. You can't compare with union 1 item or a table that has 1 column with a table that has 3 columns, because it'll throw a whole bunch of errors. And then we're going to see what type of data the columns have in them so that we can actually display them. So determine the number of columns required in a SQL injection union attack. And don't worry too much about this. This is something that a lot of this is going to be automated, and you'll go into a little bit further as, again, you start doing more web app hacking. There are exactly 2 ways to detect columns, or the number of columns rather. The first one involves injecting a series of order by queries until an error occurs. So for example, we would do order by 1, and then we have order by 3, and so on and so forth. So order by 1, order by 2, order by 3, and we're going to see how many columns. So that number there is the column that we're indicating, so either the first column or the third column in this case. And then when we finally get an error back, or in the case of a blind SQL injection, when we get nothing back, or there's a change in the page that indicates an error, that's when we know that we've hit, we're above the number of columns that are actually there. The last value before the error would indicate the number of columns in that case. The second one, method, and the most common and effective, would involve submitting a series of union select payloads with a number of null values. And this is personally the method that I prefer, where we can see that we have union select, and we have, this would be for 1 column, and you can see we have 3 columns tested down here, which is just tested by adding nulls to the end of it. And that way you can go through, and it's very visual. That way you can actually see the number of columns by the number of nulls. Again, which way you do it is up to you. It doesn't really matter. Sometimes you need to bypass a filter, and you can't do it in one way. Just worthwhile being aware of both methods. So no error would equal the number of column, or number of null matches the number of columns. So we're going to get errors until we don't have an error. Generally, the interesting data that you want to retrieve will be in a string form. Having already determined the number of required columns, for example 4, you can probe each column to test whether it can hold string data by replacing one of the union select payloads with a string value. So what we're doing here is we're taking one of these nulls and we're just popping an A or some sort of string in there, and we're seeing if it can actually match up with that column. So in the case of 4 columns, you can see that we've added an A there, and we're just rotating it through, and in this case we've got it in the 4th position, just to see what the data type is in the column. If it's strings, this will be acceptable. No error means that the data type is useful for us, so a string. Using a SQL injection, a union attack retrieved the interesting data. And you can do this again on the trial environment if you want to. This is something that's more useful at this stage to know about rather than necessarily be able to do. You can definitely learn and try it on the demo environment though. When you have determined the number of columns and found which columns can hold string data, you can finally start retrieving interesting data. Suppose that the first two steps showed exactly two existing columns with useful data or with a useful data type, and the database contains a table called users with columns username and password. Now, if these are stored in clear text, especially the password, that's problematic. In this situation, you can retrieve the contents of the user table by submitting the input. We have the single quote union select username and then password from users. Here's a small list of things that you want to retrieve. This is just a nice little cheat sheet. This first one here is going to get you the name of the database. This is going to get you the user that you're running as. This is going to be the database version, seeing if you can get the username, the password, and then table and column names. SQLMap. I mentioned this a little bit beforehand, but SQLMap is an open source penetration testing tool that automates the process of detecting and exploiting SQL injection flaws and taking over database servers. It's an incredible tool that can be learned within minutes, and it's already included on the TryHackMe attack box, or you can just install it locally by either running this, or if you are using Kali, it should just be an apt, and it's also installed by default on Kali too. Here are some of the most common options that you would configure with using SQLMap. So we have --URL, which is going to be the URL for the attack. In that case, it's going to be way up there. Just ID equals, or whatever the URL is that you're attacking. The DBMS is going to be the database type that you're running. So if you don't want to have the SQLMap guessing, this will speed it up. Dump is going to be dump the data within the database that the application uses. Dump all is dump everything in the database. And then we have batch, which is SQLMap will automatically run and just won't ask for user input. It's just going to go for it. This can be a little bit of a dangerous option. You don't want to run this typically automatic or in an automated fashion, because whenever you're interacting, especially with the production database that has data in it that may be a pain in the butt to restore, you probably don't even want to run SQLMap against it. So just be aware of that. Don't run this against something you don't own is my typical advice for this, or don't have explicit permission to be running SQLMap against it. So let's show an example of a SQLMap command. Let's say we have a vulnerable login form at http://login.php. We would use this alongside --URL to tell SQLMap where to attack. So for example, we have SQLMap --URL and then our website there, where we can then proceed to enumerate what data is in the application's database by using commands such as --tables and --columns, leaving our final SQLMap command to look like this. So we have --URL, HTTP, our actual website, and then we want to find the tables and then the columns in those tables. You can find a cheat sheet and more snippets of SQLMap commands here. So SQLMap and Burp Suite. The most beneficial feature of SQLMap is its integration within Burp Suite, and we've actually used a little bit of this beforehand, but we're going to actually take a request from this and pass it to SQLMap, because we'll find something that we want, and that way we don't even have to type in the URL. It's just going to grab it all from the request. With Burp Suite, you can capture and save login or search information to use with SQLMap. This is done by intercepting a request, and you'll need to configure your browser to use Burp Suite as a proxy for this request. The attack box it already has this done. We've done this in, I want to say, day 2 when we were brute forcing, so just something to be aware of. Or it might be day 3, there we go. So you just click up here on the top and we can select Burp to use this. And in this case, I'm actually going to go ahead and get Burp started because we're going to need it here in just a little bit. And this is a great feature to know about. This is probably one of the best features that you will use with Burp with passing things to SQLMap. So we'll let that start there. And I'm just going to click through the default options as well. And we don't need to update. And we'll just start Burp. First, let's start Burp Suite which is going to be located in the application. So if you go to Applications, Web, and you can see Burp Suite here. You can also just grab it if you mouse over here, and then you can see it in the icons. Use Firefox to visit the application that we suspect to be vulnerable, and we'll move that. And we can see that we've got this here. We're going to turn on our proxy, and I'm actually going to take off my intercept here. This doesn't mean that the traffic isn't going through here. It just means it's not going to ask me every single time. So we're enabling our proxy in Firefox, which is done there. Submit a request on the web application we suspect to be vulnerable. And we'll go through this in just a moment as well with the challenge. So we would submit a web request. So for example, trying to log in, and we're going to see it pop up in our proxy tab, where it's going to be right here saying that, hey, do you want to forward this? What do you want to do with it? And then we can set it to repeater. Notice how our request is now in repeater, and again, we'll go through this in just a moment. You can do this by doing Control-R when the request is up here, or right-clicking and then selecting Send to Repeater. However, in this case, we're going to send things to repeater, and then we're actually going to save this. And then we can use the SQLMap-R, and then just our file name, is we're going to save our actual the request this way. SQLMap will automatically translate the request and then try to exploit the database for you. It's not always successful with this, but it does its best effort, and it's usually pretty good. So the challenge: visit the vulnerable application in Firefox, find Santa's secret login panel, and bypass the login. Use some of the commands and tools covered throughout today's task to answer questions 3 through 6. Santa reads some documentation that he wrote when setting up the application, and it reads: Santa's to do. Look at alternative database systems that are better than SQLite, so we know our database system there. Also, don't forget that you installed a web application firewall, a WAF, after last year's attack. In case you've forgotten the command, you can tell SQLMap to try and bypass the WAF by using tamper and then space to comment. Then we have some resources here, which is going to be payload all the things, the SQL injection payload list. You should start both of these resources. And then we have a SQL injection a tutorial that was made by Swallfox. I definitely recommend checking that out as well. All right, we're going to take a quick break. Once we come back, we're going to go ahead and continue on with the challenge. If you want to attempt this for yourself, I recommend pausing the video here, and then you can resume it if you get stuck, or if you want to see how I solve it after the fact. Otherwise, I will see you guys just in a moment. All right, welcome back. We're going to go ahead and solve the challenge now. So first things first, without using directory brute forcing, what's Santa's secret login panel? And our hint here is going to be that this is going to be a name derived out of 2 words from this question. In this case, we can eventually guess that it is going to be, let me go ahead and go to the end of that, Santa and then panel. And we can see that we're greeted with a login panel. Now, what we have to do first is we're actually going to bypass, here, let's go ahead and we'll put our answer actually first. And we'll submit that. So visit Santa's secret login panel and bypass the login. So now we need to just bypass the login. Let's try that with admin, and we can do or 1 = 1, and then we'll comment out the rest of it, and we'll just put admin as the password. And let's see what happens. And sure enough, we're able to log in. So you can see that with that, I just commented out the rest of the query, and I was able to bypass that login just through a simple bypass there. So it looks like the database has been updated while you were away, and we can just search for database info. Let's go ahead and try searching for just Darkstar and see if anything comes back. And a lot of nothing. I guess I'm not getting a gift this year. That's too bad. In this specific case, we're actually going to go ahead and hop back over to my other page here. I've already logged in on this one, hence why we were using the private panel. And I've put on the Burp Suite proxy. So we're actually going to intercept this request, save it, and then we're going to run SQLMap against this to see what we can get, and just let SQLMap dump out the data for us. Let's go ahead, we'll pull up Burp Suite, and I'm going to turn intercept to on, switch back over to Firefox, and we'll search for me again, and we're going to see what gifts I get this time. Hopefully SQLMap is going to do us some justice. So we can send this to repeater if we want, and then we can look at it more. But what we want to actually do is save this, and we can save it as, I like to save these as .request files. Doesn't really matter what you save it as. .request just helps me remember what it is. So we're going to save that. and you don't have to worry about already replacing what you already have. I've done this just because I've already run this before. I'm going to take intercept off so that random request that Firefox does in the background isn't going to trigger Burp getting upset with me. So now we have that saved, and we can go ahead and hop over to SQLMap, and we're going to get it to dump all the data for us. And in this case, I'm using SQLMap with the -R switch to say that we're going to use this request that we've saved from Burp, and then we're going to use this bypass that was provided for us right here. Additionally, we want to use the dump all command because we are going to need everything out of this database at some point or another. And then we're also going to signify that the database is SQLite since Santa had it in his notes right here. There we go. Saves us a little bit of time, and it makes us run significantly faster. Let's go ahead and run that now. And there we go. That's it. Very, very easy. So we're going to go through, and it looks like our first question here is going to be, how many entries are there in the GIF database? And if we scroll up, it looks like 1, 2, 3, 4, 5, 6, 7. Okay, I'm going to skip ahead because I know it's 22 here. So we'll enter that, and then we're going to see what Paul asked for, which Paul asked for GitHub ownership, and wouldn't we all like that? Paul, you have good choice in GIFs. And we'll ownership. Enter that in there, and then we should have a flag in here as well. And it looks like Kenneth wanted a TryHackMe sub. Good for him. And then we have our flag, which is going to be THM Fox all I. Actually, we're going to copy this out because it's going to be faster. So we can copy that by doing this, and then we can grab it from our clipboard. And that saves me from typoing the flag. And then we just need our admin password. So we'll close this, scroll down, and we're going to grab the admin password, and that is going to do it. Let's go ahead and copy that in, and we'll take it out from the machine. And that is going to do it for day 5. If you have any questions, as always, I'm going to have the TryHackMe Discord linked in the video description below. And I will see you guys tomorrow on day 6.